Okay, now we left with FCC structure. First, we want to know how many atoms inside of a FCC cubic structure. Well, let's do a quick count. So at each corner, we have 8 atoms, and each atom is 1/8. And at each face, in total we have 1, 2, 3, 4, 5, 6 faces, and the atom at each face, it's shared by the unit cell on the other side, so it's half. Since we don't have any atoms in the body center, that's all the atoms we have. So let's do a quick calculation. All the atoms at a corner would give us 1 atom, and all the atoms on each face would give us in total 3 atoms. So in total, we have 1 plus 3, that is 4 atoms. Okay, now we know the 4 atoms. If we know the length is A for the unit cell, what's the relationship between R and A? R is the radius of an atom. Now we can start to draw just one side of the unit cell. Since now we have an atom at the center of the face, that kind of like push the atoms a little bit far away at each corner. So the cross-sectional diagram gonna look like this. So they will touch. The atoms at corners, they won't touch with each other. However, the atoms at the face center would touch with all 4 atoms at the corners. Now we know the length of this cube is A, and we know this is R, this is R. However, we don't know what's the space between these two. However, if we draw a diagonal line, we do know this diagonal line consists of 1R, 2R, 3R, 4Rs. So we can use this help us to find the relationship. Look at this, we have a triangle. Now we have a square plus a square equals 4R square. Let's do a quick calculation here. Got 2a squared equals 16r squared. A can be written as 8 times r squared. Then you can write A can equal to square root 8 times r. Or another way, you can write r, it's square root 1/8 a. Okay, now we find a relationship between a and r. We can start to calculate what is APF. APF, and find out what's the total volume of atoms inside of this unit cell. We have 4 atoms, so 4 atoms times the volume of each atom. It's going to be 4/3 pi r cubic. The bottom, it's the volume of the unit cell is going to be the A cubic. So we know the relationship between R and A. We can substitute R equals square root 1/8 times A to find out the APF for a fifth-centered cubic crystal structure. It's 0.74. So if you remember, this is for FCC. If you remember the number we calculated for body center cubic structure, it's about 8.68 for BCC. For the simple cubic structure is 0.52. So now you can see FCC has the highest packing efficiency among all cubic structures.